Welcome in, everyone. In this video, we will be covering section 6.1, simplifying rational expressions. We're going to start with a review of our exponent properties. So our first rule we have is our product rule. So if we're multiplying two terms with the same base, we add their exponents together. So if I have x squared times x to the fourth, my solution, I would take 2 plus 4 and get x to the sixth, because I have a total of 6 x's that I'm multiplying there. Between the 2 I'm multiplying here and the 4 I'm multiplying here gives me a total of 6 x's I'm multiplying together. Our next rule is our quotient rule. Again, if we have same bases and we're dividing, we are going to subtract the top, and I'll make this look a little bit better. We're going to subtract the top exponent minus the bottom exponent. So in our example, I've got x to the fourth times y squared divided by x. And when we don't see an exponent, we default that it's to the first. Now, I've got two different terms up top that I'm multiplying together. Because they do not have the same base, these two terms don't really interact. And so all that's going to interact is this term with base x and this term with base x. And because I have x to the first down here, I'm going to take 4 minus 1, and that x is going to stay up top and become x to the third times y squared. So notice, what we have in the denominator goes away. The only reason we'd have something stick around in the denominator is if our exponent is greater in the denominator than in our numerator, or if we have a negative exponent up top, and we'll talk about that a little bit more in a little bit. Next is our power rule. If we're taking a base to an exponent to another exponent, we multiply the two exponents together. So in our example, we have x to the third all to the fourth power. So we take 3 times 4 to give us x to the 12th. Next rule is when we have a power of a product, so we're multiplying two things inside the parentheses. Normally you don't want to simplify if possible inside the parentheses, but because I don't have like bases inside here, I can't simplify anything in this parentheses. So in a sense, I'm going to distribute that exponent that's on the outside to all the exponents that are on the inside of the parentheses to give us x to the m times p times y to the n times p. Okay, so in our example, we have two things being multiplied together, 2 and x to the third, and then we have this exponent on the outside. And because I'm multiplying two things, I need to think that this 2 has an exponent of 1. So when I have that power that's on the outside, it gets distributed to everything inside that parentheses. So that's going to become 2 to the third, because 1 times 3 is 3, x to the ninth, and then I'm going to simplify that further because I know 2 to the third is 2 times 2 times 2, which would give us 8x to the ninth. Okay, likewise, when we have a power of a fraction, if we can simplify what's inside the parentheses, we want to do that first. Here we can't do that, so I'm going to again distribute this exponent to all of the exponents both in the numerator and the denominator. So that p gets multiplied by the exponent of x as well as the exponent of y. So looking at our example, we have 3 over x to the fourth all squared. Okay, everything inside this parentheses is going to get squared. So I want to think, again, this is 3 to the first, so when I distribute that 2 to all of the exponents, it's going to become 3 squared over x to the 8th, which we would simplify to be 9 over x to the 8th. And with our fraction, because we don't have like bases in the numerator and denominator, we would just leave it as is. Next rule is one of my favorites because it just states anything to the 0 power is going to be 1. Okay, anything to the 0 power equals 1. So if I have 10,428 times z squared all to the 0 power, that's just going to come out to be 1. Okay, and then our negative exponent property states that if we have a negative, exponent, it is going to simply jump either to the denominator or to the numerator. So if we have just a regular term with a negative exponent, it's going to jump down to the denominator. What's important here is if we don't have any terms up top with a positive exponent, we have to have this 1 as our placeholder. Okay, another way to think of it is, let's say we have x to the m over y to the negative n. We have this negative denominator we have this negative exponent in the denominator. That whole term with that exponent is going to come up to the numerator. And it's essentially that 1 placeholder is in the denominator, so it becomes x to the m times y to the n. And again, my stylus is not the best this morning. X to the m. So let's say we have x to the negative 2, y to the 4th, z to the negative 10. Our negative exponents are simply going to jump sides in our fraction. Let me make that look like a z. There we go. So if it has a positive exponent, it's just going to stay there. And this negative exponent only applies directly to the base. So all that's going to go down in the denominator is this x to the negative 2, and when I bring it down, it becomes x to the positive 2, and this z to the negative 10 is going to come up and become z to the 10. So we have y to the 4th times z to the 10th over x squared. And usually all of these steps can kind of be done in any sort of order, just as long as you're following them exactly. What I usually like to do is simplify what's inside the parentheses if we have any parentheses first, and then distribute. And then my last step is usually going to be our negative exponent, just to clean everything up. So as we look at a couple examples, I've got 14 x to the 4th times y to the 7th over 6x to the 5th times y to the 4th. So because we have a fraction here, we're going to use our quotient rule. Okay, we're going to end up subtracting. Okay, but when we have coefficients, we want to really just simplify it as if it were a fraction. So if we had 14 over 6, we know we can divide both 14 and 6 by 2. So that 14 over 6 is going to become 7 over 3. And then looking at x to the 4th over x to the 5th, we'll have a quotient rule, so this can become 4 minus 5. So for right now, I'm going to write it as x to the negative 1, because it stays up top when I use subtraction. And then our y to the 7th divided by y to the 4th is going to become y to the 3rd. Now to clean it up, because we have that negative exponent, I'm going to move just the x to the negative 1 in the denominator. Okay, x is the only term that has a negative exponent, so it's going to be the only part that comes down to the denominator to make that exponent positive. So I have 7y to the 3rd over 3x to the 1st, and because anything to the first power is itself, I'm just going to leave it like that. Okay, so let's go ahead and look at C. Okay, so with C, when I talk about things with parentheses, I want to first clean up what I have in the parentheses first. We don't have any like bases, however, I have y to the 0 power right here. Okay, and y is the only thing being taken to the 0 power, so that's going to become 1. So I can simplify this to be 4x to the negative 1, because that y to the 0 power makes it just go away. And so I'm going to distribute this negative 1 to both the x and the 4. So I have 4 to the negative 1, x to the negative 1. Since both of those terms have a negative exponent, it's going to simplify to just be 1 over 4x. And right there is our solution. Okay. And then with E, we have x to the negative 1 over 4x to the 4th, all taken in the negative 2. So again, I'm going to clean up what's inside this parentheses. Okay, I have two like bases, So this is going to become x to the negative 1 minus 4. So I'm going to rewrite what I have in parentheses to be x to the negative 5th over 4, all to the negative 2. And then I'm going to use my power of a fraction rule and distribute this negative 2 to the negative 5 as well as to the 4. So it becomes x to the 10th over 4 to the negative 2, which is going to become 4 squared times x to the 10th, which we would simplify to be 16x to the 10th. Okay, so again, you can do these rules a little out of order. Like I could have just flipped this fraction to make this a positive 2, but I kind of like just keep it streamlined, simplify what's in parentheses, then distribute, then worry about the negative exponents at the end. Okay, so I want you all to do B, D, and F on your own, and you can check our notes key in Canvas to check your answers before we move on. So go ahead and pause the video, knock out B, D, and F, check your answers, and then once you've got everything lined up, looks good, you can move on to the next part of the video. So, next part of our video is going to incorporate factoring, and when we simplify fractions with polynomials, both in numerator and denominator, we want to look to factor and then cancel out like factors. Now notice, factors, the definition of factors are items being multiplied. Okay, so we have to have like factors in order to cancel out. Okay, if we're adding terms together, they cannot cancel out. They need to be multiplied, either binomials or monomials together. Okay, so as we look at G, looking at our numerator in G, we have x plus 4. We can't factor that. It's a binomial. It's a linear binomial. Neither of these have a greatest common factor. So I'm going to look in the denominator at x squared minus 16 and look to see if I can factor that. I don't have a greatest common factor between these two. However, I see I have a difference of squares here, which I can factor x squared minus 16 to be x plus 4 times x minus 4, which now that I've factored it, I see, and you could think of this as n being in parentheses, I have a like factor here because it's just x plus 4 times 1, and a like factor here. So because I have a like factor in the numerator and the denominator, both of these are going to cancel out. So all I have left is 1 in the numerator and x minus 4 in the denominator. So as we look at H, looking at my numerator, I have a greatest common factor. I can divide both of these terms by 3x. So I'm going to factor out that 3x from both terms to make it x plus 2. And then looking in my denominator, I've got x squared minus 2x minus 8. So because I have a quadratic that I can factor to be x minus 4 times x plus 2. And now I see my like factors. I have 3x times x plus 2 in the numerator, x minus 4 times x plus 2 in the denominator. So both of those will cancel out, leaving us with 3x up top and x minus 4 in the bottom. Okay, I don't have anything else that I'm multiplying together. Keyword multiplying, that cancels out in our numerator and denominator, so we just leave it as 3x over x minus 4. Okay, so if I look at I, okay, right off the bat, looking at I, you may say, oh, I've got an x squared here and an x squared here, so they cancel out. But even though I'm only taking x squared times 1 down here, I have x squared plus 7x down here, or up here. Okay, so these do not directly cancel out because they are not being multiplied. Okay, I'm not taking x squared times 7x because I have this plus here. They don't get to interact yet. Okay, so again, let's just look at the numerator. Do I have a greatest common factor? I have one of greatest common factor of x, so I can factor out an x from both of those. So it becomes x plus 7. And then in my denominator, I've got x squared. Well, if I want to write this out as factors, two things being multiplied together to get x squared, I would have x times x. Okay, so now looking at my numerator and my denominator, I have a like factor of x both up top and on the bottom, so those both cancel out to leave us with x plus 7 over x. Okay, so as we look at J, looking up top, usually when we have binomials, we're going to be looking for a greatest common factor unless we have a difference of squares. Okay, but looking at 2x squared plus 10x, my greatest common factor is going to be 2x. So that leaves us with x plus 5 when we factor out that 2x. And then looking at our denominator, we've got 3x squared plus 16x plus 5. I can factor that to be 3x plus 1 and x plus 5. Okay, because if I multiply 3x times 5, that gives me 15. 1 times x gives me 1x. 15x plus 1x would give me that 16x. 3x times x would give me 3x squared. 1 times 5 gives me that 5. So we'd factor out everything in the numerator and denominator, look for common factors, which we have a common factor of x plus 5, both in the numerator and denominator. So this would just simplify to be 2x over 3x plus 1. Okay, so I want you all to do J, or it's not J, K, L, and M on your own. Once you've completed that, check it against the notes key that I have in Canvas, and then you will have time to watch the 6.2 video and then work on your assignment. Okay, I'll see you all later. Bye.